Math 122. Week number 9. This will be our second video on the histogram. First one, you made the histogram. I used my Los Angeles Lakers, their point score. We came up with something looking like that. You got your own videos, your own data sets. Hopefully you have a histogram. Once we have that in place, now we have a couple analysis questions. The first of which is, tell me what kind of distribution we're dealing with. Skewed, uniform, normal. Well, what's this all mean? Well, once you have your histogram, they have a quote-unquote shape. This one starts to go up and then sort of levels off. I'm going to compare that to 3 different distributions. One distribution is this normal one, which is, look at, they're kind of about the same height. Yeah, little dips and stuff, but they're about the same. There's a skewed distribution. It goes up and then it tails off. And there's normal, which is up and down, but a little more symmetric. Look at my data. Which one does it match up with? It's like multiple choice. This is a judgment call. You could say, oh, it's like normal. It's going up and then kind of coming down. Or you could say, well, it's sort of level here, so it might be kind of like uniform. I'll pick uniform in this situation. You could definitely sell me on the normal. Skew doesn't seem to fit in this case. Either way, you've got a graph. Here's 3 distributions, and you need to match it up. You need to make it's like a multiple choice. You need to match it. Second analysis question, a little more involved. Maximum and minimum, you're going to tell me if they're unusual. And I'm not just going to say, wow, it's pretty big. That's unusual. We have a formula to do that. In particular, given your data set, you have to identify the max, identify the minimum. Okay, that's pretty simple. But then we need to employ these 2 formulas. I call them the cutoff formulas. They tell me the top of the data, the maximums, and the bottom of the data, the minimums, and everything outside of those cutoffs is unusual. All right, well, that seems simple enough, but wait. How do we find the mean and the standard deviation? Let's take that and go back to Excel. All right, so here's my data, my Lakers data. You've seen me use that many, many times. And here's those 2 formulas I was talking about, the mean and the standard deviation to find the cutoffs. How do we find mean and standard deviation using Excel? Well, equals makes Excel think like a computer. It gives all these formulas at our disposal. In particular, I want the average. So I start to type average, and you see it right there. Double click. Then a little parenthesis says pick some numbers. Well, sure, I'll pick those numbers. Close up that parenthesis. I hit enter. It just told me, Excel just told me, the average score is 106.6. I can take that number and put it into these formulas. We'll do that in a second. What's the other part of my formula? SD, standard deviation. Equals. Got to have the equals first. Standard, and I've got to abbreviate STD. And you see it gives me all this list of crazy formulas. I go for STDev. Either this P and this S. You can use those ones either. The difference is minimal. But I'm going to STDev. Gives me the parentheses. Pick some numbers. I'll pick those numbers. Close up my parenthesis. Excel just did a magical, it feels like magic. It gives me this calculation. It gives me 2 numbers. I can put them into these cutoff formulas, and then I can talk about maximums and minimums. Let's go back to the slideshow, though, to do that. So, all right, we got these things. We've got we have the mean, and we have the standard deviation. Well, that's from Excel. We have these 2 formulas. Now we got to find those cutoffs. And I could just do the calculations, but I want to do visual for you. I want to make a number line. So think about what the average is. Average is the middle, right there in the middle. What is this minus the minimum? Means, okay, I'm looking at these 85 and these 88s. Minimum means, well, look at that. I'm going down twice. How am I going down by? I'm going down by the standard deviation. So I go down twice by the standard deviation. Oh, that 12.5. So you see where that 12.55 shows up. It tells me starting from that mean, I go down twice. And how much do I go down? 12.55. That's a calculation. Let's go down once and get 94. And then we go down, subtract. Again, now we're at 81. That 81, that is our cutoff. I was talking about these formulas, I call them cutoffs. Everything below that cutoff, we're going to call unusual. Okay, so now go back to the data, back to the Lakers, the points they scored. Look at that 85. 85 is down here. Not quite unusual because you notice if I plotted it, it doesn't have to be precise, it's not quite below that 81. So this is a very involved process. You got to go to Excel and get these numbers. And then you got to plot this number line and then try and figure out where the unusual cutoff is. That's a lot of steps. Let's do it again with this maximum one. See if it makes, it starts to generate some understanding what's going on. So maximum, okay. Maximum means I'm looking at this 125, 126. Maximum means I go up twice. So up twice means I'm going to go, yeah, okay, going up. And once again, that 12.55, my standard deviation. So let's do the calculations. Starting at the mean, starting at the middle, I go up and I get this 119. And then I go up again and I get 131. That 131, after I went up twice, that's my cutoff. Everything above it is unusual. So if I say take 125, I plot it on the line. It's right around it. It's an approximation. It's approximately there, but it's not above that 131, so it's not unusual. Oops. That 125 is not in that blue zone, so it's not unusual. Try that with your own data. Post all that up onto your the discussion board. Make some responses to your classmates' posts, and I'll be looking for that this week.